Download this code from codegive.com, link in the description below. OK, let's dive deep into circular doubly linked lists, specifically focusing on the process of deleting the last node. We'll cover the concepts, logic, edge cases, and provide a complete code example in C++. Understanding circular doubly linked lists. Before we tackle deletion, it's crucial to understand what makes a circular doubly linked list unique. Asterisk doubly linked asterisk each node in the list holds two pointers, next, pointing to the next node in the sequence, and previous, pointing to the previous node. This allows for traversal in both forward and backward directions. Asterisk circular asterisk the next pointer of the last node points back to the first node, and the previous pointer of the first node points back to the last node. This creates a closed loop, eliminating the concept of a null end of the list. Why circular doubly linked lists? Circular doubly linked lists are useful in situations where you need efficient traversal in both directions and a seamless loop. Common use cases include asterisk round-robin scheduling asterisk when processes or tasks need to be executed in a continuous cycle. Asterisk music playlists asterisk where you want to loop back to the beginning after reaching the end of the playlist. Asterisk undo/redo functionality asterisk maintaining a history of actions with the ability to move forward and backward through the history. The node structure. Let's define a basic node structure for our circular doubly linked list. Asterisk T data, this holds the actual data stored in the node. T is a template parameter, allowing you to store any data type, example int, string, custom objects. Asterisk node T asterisk next, a pointer to the next node in the list. Asterisk node T asterisk previous, a pointer to the previous node in the list. Asterisk the constructor initializes a new node with the provided data and sets both next and previous to null. We'll handle the circular linking later. The circular doubly linked list class. Now, let's create a class to manage the circular doubly linked list. Asterisk head, a pointer to the first node in the list. It's the entry point for traversing the list. If head is null, the list is empty. Asterisk size, an integer to keep track of the number of nodes in the list. This is optional but often useful for efficiency. Asterisk the constructor initializes head to null and size to 0, representing an empty list. Asterisk the destructor circular doubly linked list, is essential for deallocating memory when the list is no longer needed. Otherwise, you'll have memory leaks. Asterisk is empty, checks if the list is empty. Asterisk getSize, returns the number of nodes in the list. Asterisk insert front, inserts a new node at the beginning of the list. Asterisk insert back, inserts a new node at the end of the list. Asterisk delete front, deletes the first node from the list. Asterisk delete back, deletes the last node from the list, our primary focus. Asterisk display, prints the data of the nodes in the list in forward order. Asterisk display reverse, prints the data of the nodes in reverse order. Implementing delete back, deleting the last node. Here's the implementation of the delete back function, along with a detailed explanation of the logic. Explanation asterisk. 1. Handle empty list asterisk. Asterisk the first if statement checks if the list is empty. If it is, there's nothing to delete, so we print an error message and return. 2. Handle single node list asterisk. Asterisk the second if statement checks if the list contains only one node, size equals 1. Asterisk if so, we simply delete head, the only node, set head to null to indicate an empty list. 3. Handle multiple nodes asterisk. Asterisk node T asterisk last node equals head dash previous, this line is crucial. Since it's a circular list, head dash previous points to the last node. We store a pointer to the last node in last node. Asterisk node t asterisk second last node equals last node dash previous, we need to update the links. We get a pointer to the node before the last node, which will become the new last node. Asterisk second last node dash next equals head, we update the next pointer of the second to last node to point to the head, making it the new last node in the circle. Asterisk head dash previous equals second last node, we update the previous pointer of the head to point to the second to last node, completing the circular connection. Asterisk delete last node, now that the list is properly relinked, we can safely delete the last node from memory using delete. For decrement size asterisk. Asterisk finally, we decrement the size of the list to reflect the deletion. Implementing other helper functions, for a complete example. To make our example complete and testable, let's implement the other functions mentioned in the circular doubly linked list class declaration. Complete code example, C++. Here's the full, compilable C++ code. Key points to remember. Asterisk circular logic asterisk always remember that the last node points back to the first, and the first node points back to the last. This is the core concept. Asterisk memory management asterisk use new and delete carefully to allocate and deallocate memory. The destructor is crucial to prevent memory leaks. Asterisk edge cases asterisk handle empty lists and single node lists separately. Asterisk thorough testing asterisk test your code with various scenarios to ensure it's robust. Insert nodes at the beginning and end, delete from the beginning and end, and test with an empty list. Asterisk visualization asterisk draw diagrams of your list structure before and after each operation. This will help you visualize the pointers and avoid errors. This detailed tutorial should give you a solid understanding of how to delete the last node in a circular doubly linked list. Practice implementing this and experiment with other operations to master the concept. Good luck.